Dr.
Recording is good. Recording is good.
Okay, thank you so much. Thank you.
No problem. And we'll begin if that's okay. And once again, I apologize for the difficulty connecting. What I'm going to share with you, and there's a lot on the slides, but I'll make those slides available to you as well. My goal is to share with you some ideas about discipline-based research. And discipline-based research is providing a lot of opportunities for STEM faculty to look at their teaching and learning practices and develop some research around those particular aspects of their profession. So it moves away from what you might do in a lab in your research with physics, and it focuses on your enterprise as faculty members who may have a course or faculty members who are doing outreach to various groups and looking at perspectives about teaching and learning. So we can go to the next slide. So what is discipline-based research? Well, it's just the scholarship of teaching and learning. And what it is a bridge between educational research and the scholarship of teaching and learning. So you can see it's often abbreviated DBER, and it is looking at a particular discipline. So in your case, it's likely physics. So how do you look at physics and reflect that to the values, the practices, and the priorities as it relates to teaching and learning? Next slide. So here's the current status of DBER, and I'll just use DBER instead of saying discipline-based education research each time. And it's a field that has evolved over the last 10 years. And I think it's really relevant in terms of the proliferation of publishing opportunities. And so here are some of the primary goals. It's to really understand how people learn. Secondly, to look at the nature and the development of expertise in a discipline. For example, some of you may teach physics, the introductory physics course at your university. So you may be focusing on, well, what does it mean for a student to develop a basic understanding of physics? Thirdly, it helps to identify and measure learning objectives and instructional approaches. Fourth, contributes to the knowledge base to guide translation of DBER to classroom practice. And fifthly, it identifies approaches to make science and engineering education broad and inclusive. And then there are 4 types of knowledge that and as we're talking about this, think about your own practice and where you might see intersections. But DBER includes deep disciplinary knowledge. So what does it mean to be to know physics, and what knowledge is important for those who are studying physics? Second, the nature of human thinking and learners as they relate to a discipline. I know in mathematics education, which is more of my area, there are particular practices that are effective in promoting learning. So that's what that second bullet gets to. Are there particular things in physics that are relative to promote thinking and learning? What does it mean to think like a physicist, for example? Thirdly, students' motivation to understand and apply findings of a discipline. How do you get students motivated to study physics? And then lastly, what are the research methods for investigating human thinking, motivation, and learning. All right, next slide. So here are some things that DBER has provided to the literature. Information on conceptual understanding and conceptual change. In all disciplines, undergrad students have things that they believe that aren't true. I'm sure you have misconceptions in physics as well. So it has exposed a lot of those. It has provided research on how difficulties that students have with concepts. And then thirdly, also instructional strategies that have been shown to be effective. All right, next slide. Problem solving and the use of representation. So I'm thinking of what little I know about physics, and this would be such a rich area because there's so much of the representation about what happens in your field. So it's looking at the domain, in this case, physics, and what are students challenged by and how can they overcome that to engage in complex problem solving, and how are representations such as graphs, models, and simulations used to promote that learning. And then secondly, students can be taught more expert-like problem-solving skills and strategies. So what kinds of approaches can you emphasize in physics that it would help students be able to do application problems? All right, next slide. And then research on effective instruction. So that includes things such as research-based approaches such as POGIL, I think is, maybe some of you are familiar with POGIL, peer-led team learning, and et cetera. And then what kind of learning processes might be effective, such as interactive lectures, authentic problem solving, how do you use formative assessments? Is there a role for metacognition in teaching physics? All right, next slide. I won't go through all of this text, but as you can begin, hopefully you're beginning to think that there's a lot of opportunities in teaching physics to engage in research around the teaching and learning. So this is sort of the agenda that the field has, but studies of similarities and differences among your students, longitudinal studies, you might try something over 2 or 3 years to see what the lasting effect is on student learning. Basic research in learning across the STEM disciplines. For example, you might think of a collaborative kind of research between physics and mathematics, for example. And then the translational role of DBER to research and development on change initiatives. So if your university is universities are often talking about how to change the introductory chemistry and physics and calculus courses for students. So that is a rich area for discipline-based research. All right, next slide. So how do you prepare a research proposal? And I won't go through all of these 10 steps, but what I will offer to you is, as you think about your work and you think about DBER, if you have an idea, I'd be happy to engage in correspondence, or we could set up a Zoom or WebEx meeting and talk about your research. I think you'll find that there are very open and fruitful opportunities for scholarship, both in terms of publications, but also in terms of conference presentations and that sort of enterprise. And what I'm finding across the United States and Canada, where I have most of my connections, and even in some European countries that I've worked with faculty, such as in Poland and the Czech Republic and Spain, universities are getting much more open to the idea of STEM faculty engaging in research that has an educational kind of focus. And I think that's a big move forward for a lot of universities and a lot of departments. So the idea of doing research on your teaching and learning, I think, is much more open in terms of what universities are open to in terms of giving you credit for scholarship in your discipline, because it is discipline-based educational research. So it still has that very strong physics piece. And another thing to keep in mind is look at funding opportunities that are available for your country. For example, in the US, there are numerous opportunities for STEM research. And those include a lot of opportunities that focus on STEM physics education. And even if you're doing a research project in your lab that's pure physics, there's often, and sometimes the call for a grant proposal will spell this out, but there's always an encouragement to find a way to apply that to a larger community. So a lot of grants that faculty get at UNC Charlotte, for example, that are in biology or in physics or in pure mathematics, the funder wants them to have an outreach or an educational component. So I'm working right now, for example, with a mathematician who has developed an algorithm to shorten the time for processing financial data online. And he's writing an NSF proposal to continue work on this, and he's applied actually for a patent. But he also wants to have an application piece. So we're looking at ways that perhaps we could work with a group of high school teachers to teach. That would give them some knowledge of finances, but it also gives them some knowledge of coding and algorithms and how those play out in this emerging world of AI. And since I mentioned AI, I'm sure there are AI applications in physics. So that would be a really rich opportunity for research and for funding opportunities. So keep that in mind as you look back through the steps for research. Here's some resources that I think you might want to begin thinking about if you're interested in publishing. If you look at these, there are just dozens of journals that have opportunities for you to publish in. So if you click on any one of these links, it's going to take you to 10 to 15 or so journals. And you could click on any one of those and get some better ideas about where might you print or submit your manuscript related to discipline-based education research. And so this is a really great resource that I hope you will use. Don't spend a lot of time on it. Once you conceptualize your research study, I'm happy to talk with you, and then we can explore a lot of these together and maybe identify 2 or 3 possible outlets that would be open to your research. I'm currently, let me give you an example of what I'm talking about. I'm currently a co-PI on an engineering National Science Foundation grant that's focused on the doctorate. And what this program what we've done is developed a track where students can go through the entire patent development process and submit an application for a patent instead of the traditional dissertation trajectory. And so I just finished a manuscript that I submitted to Cogent, Cogent Education, which is publishing a lot of STEM education type of research, and it's been accepted pending revision. So that's just an example of, and that's just one of many of the types of journals that would be available to you. Okay, I think there's another slide. This is just a little information about the center so that you know who the center is. We've been in existence for 30 plus years at UNC Charlotte, and we're sort of reconceptualizing our role and mission, and part of that includes we want to collaborate more on STEM education priorities. And we want to develop initiatives that support that. So such as this talk is a really important piece of making that connection. Support grant and external funding, and emphasize our research on external funding for center programs. And our center programs revolve around STEM, teaching and learning, PK through 20. So we have programs that are at the elementary school level, all the way up through, as I just mentioned, the doctorate level at UNC Charlotte. So, and just some ideas there, some things we have done, and the website that we have. So I know that was quick and a lot of information for you to think about, but what I feel would be so beneficial is making those cognitive connections in your mind between physics and physics teaching and learning, and begin to think about how can I develop a study of something that I'm already doing that would fit in with this idea of DBER. And if I do that, what would that study look like? And that was sort of that designing the research study slide that I sort of slipped over. And as I indicated, I'm happy to talk with you as an educational researcher about that process and what components you need to make it valid and strong for a journal to consider. And then all of the resources of all of the STEM education journals that are available. And I'll be honest with you, the number of journals that have that are available is just there are new ones seems like every couple of months I get information on a new journal that someone is starting. So there are lots of opportunities, and I'd be happy to explore those with anyone who has an idea and wants some support on a possible study. And if there are opportunities down the road for us to collaborate on some kind of funding request, be happy to conceptualize and work with you on those ideas as well. I guess we'll do questions, or I'll turn it back over to our leader.
Yeah, thank you so much, Professor Fagali, for this. Actually, we wanted this kind of presentation. Thank you so much for this. And if the audience have any questions, please put in the chat box, or you can unmute and ask your question to the speaker. Thank you. Dr. Malcolm, you have any question?
Yeah, can I ask you one
please,
question?
Please.
Yes.
Yeah, this question might be too personal, but I guess maybe we can discuss later, or your answer may be also useful for others. So what I have a situation here is we got a small grant from college, and that grant is related to improving college completion. And
Okay.
we said there are many students they fail, and that may also lead to dropping the whole program. So we like to improve the completion rate. And what we proposed was we are going to give peer kind of tutoring, right? And then also another proposal was we use scale up in physics, but that's only in the one section. And we like to use some of the techniques we learned from scale up to general class.
Oh.
So in that program, is there anything research component we can use during this budget period?
Yeah,
Do you have any suggestion what I can do?
Yeah, I have a few just quick ideas, but if you would reach out to me via email, and I get a little bit more detail about what you're doing, I could provide you perhaps more in-depth information.
Okay, sure.
But just based on what you're saying, there are a couple of options for studies. You go to your improving program completion, then identify the things that you put in the program that are supposed to help students matriculate through the program and graduate. And you could do a study just describing those and how they were used and tracking the students to see, well, did the program completion actually improve? And there are lots of tools that you could use for that, and they could be physics content measures that are done in the courses. Project completion rates would be something you might consider, even some interviews with faculty or focus groups with students. So that might be something that you do for that program. The second one, where you're taking some strategies from a program that has already shown to be successful, just taking those strategies and showing how you implemented them and what was the impact on student learning, like the peer tutoring. What topics are what are the key topics, and when students have assignments or exams with those topics, are they showing improvement in their understanding? So I think both of those would be ideas that you could easily sit down and develop a strong research study around. And there would be multiple journals that would be interested in finding out more about what happened in these two situations. So yeah, okay. Really good ideas.
Thank you.
So
thank you very much. I will definitely contact you.
Great.
Yeah, thank you.
Thank you so much, Dr. Nagarvi, for the question. So, and thank you, Professor Pagoli, for answering that. Any other questions the audience have? I have a question, like a quick question. I'm from WPI, Worcester Polytechnic Institute in Massachusetts. We had a PhysTech grant, Physics Teacher Education Coalition, to work to develop physics teacher, high school physics teachers. So our grant was over recently. That ended last year. So you also mentioned, like, how can we involve high school teachers in the area of research? I believe, like, if I am not mistaken, like, so in your talk, we have also here our teacher in residence in that program, and currently his faculty, as well as physics education researcher, PhD researcher, TJ Noviello. Probably he might have question. But before that, like, how can we work, do actually involve the high school teachers in physics education research? Like, how can we collaborate that? Like, it would be nice if you can share your experience with us. Thank you.
Yeah, one way to do that. I don't know if you've ever looked at the research experience for teachers grants, but those are and they seem to have a lot of money to support those kind of programs. But that brings teachers to campuses to do research with a faculty member. And of course, the idea is they'll go back to their schools and it will improve their physics teaching. So that's a large program. And I don't know if you've worked with that before or not, but that's something, even if you have, you might consider a new proposal that does, you can always do something slightly different. If you were looking to develop a professional development program to work with teachers, and the focus could be around helping physics teachers understand the role of research and do some research with maybe their students in their classrooms. Or it could even involve community college faculty who often need opportunities and additional support. But there would be multiple types of grants that you could get to do that. And the research that you could get from that would just be, it would be overwhelming. You'd have to decide what you were going to focus on. But when you're developing programs that, let's say you wanted to work with high school physics teachers in your area, think about reaching out. You've got colleagues here now from UNC Charlotte. Think about collaborating with UNC Charlotte so that we do the same thing you're doing. And that just gives it a larger scale. And what I'm finding more and more with NSF projects is they want universities working and talking together. And so if you have a really strong program that you feel would benefit the physics teachers in your area, in your state, think of a partner or two partners. And of course, that means you can ask for more money, but that gives you just a wealth of opportunities, because now you have 2 or 3 institutions where you can compare and collect data on how those teachers received the program and how did it change their practice. So those are just a couple of quick ideas that I think might help scale up what it is that you're doing already.
Thank you so much. Any other questions? And if you have any other questions, please put in the chat box or please unmute and ask. Probably we'll go for about, let's say, a couple of minutes before we end the program. Dr. Silva, do you have any question?
I do not have now. I'll be stopping by Dr. Pogley's office hopefully next week. I have narrowed down some research idea to carry on. Thank you.
And any of you, anytime you're in the Charlotte area, send an email. Let's get together for lunch or coffee and talk. And I'm very sincere when I say any of you that have an idea and want to talk with me. Not that I'm the greatest expert in the world, but I've had success in discipline-based education research, and I've had success in grant funding, and I'm available to help you. It would be an honor to talk with any of you about your research and give you any help that I could give you.
Thank you so much, Professor Pogley. Like, this is because of we were already late, so I did not mention anything in the beginning, but this program is happening in the platform of Association of Nepali Physicists in America. So we have 300 plus active members. Like, many more like people are coming to the United States for their
Right.
master's and PhD studies. And also in this particular program, there are number of participants from Nepal. So it is around 9, maybe 10, 9:30 or 9
Yeah.
PM of Saturday
Yeah.
in Nepal. So they are participating from different parts of Nepal and
Yeah.
also from different universities in the United States, like from California to Boston or Florida. So we are really grateful. Thank you so much for this presentation. We will definitely be in touch. Dr. Silwal is right next door to you, and so we'll be collaborating
Right.
in future. Thank you so much.
Yeah, and just one closing comment for those who weren't able to join live but are going to listen to the video. Everything I said applies to you as well. So if you have any questions or want to talk, just shoot me an email and we'll do an email exchange. And if you want, we can find a time to connect, regardless of where you are in the world. We can find a time.
Yeah. Thank you so much. So please enjoy the rest of your conference in Texas. Yeah. So thank you.
Thank you. Take care.
Thank you
Thank
so
you.
much.
Thank you very much.